Good. Shall we start?
Yes, please.
Okay. So today we will discuss some literature work on solar technologies and their applications.
Yes.
And afterwards, as per your interest, we will be discussing some solar parameters.
Okay.
Okay. So because they are useful for understanding further topics, maybe you have sent me some thesis works and all right.
Yes.
So there several parameters are there. So for understanding those things, first we will discuss the parameters.
Okay.
Okay, let me
Good.
share.
Sure.
Is it visible?
Yes, it's visible.
So yeah, literature survey is anyways it is required for your document and presentation purpose, initial presentation, right?
Yes.
Yes. So here you send this paper to me. So here in this paper, solar energy technology and its roles in sustainable development is discussed. So we can see the importance of solar energy and based on their installation capacities in various countries and even coming to the sustainability and economics, there are several jobs were created due to the introduction of these renewable energy sources. Mainly, solar has created several jobs. So
Yes.
that we will see. Okay, so if you want to introduce your research topic and if you want to use solar energy or even renewable energy sources, you should know Paris Climate Agreement. So it is given in and it is signed in 2015. So it has addressed the mitigation of climate change, adaptation, and finance. So consequently, the representatives of 196 countries concurred to decrease their greenhouse gas emissions. So this is known as Paris Agreement. So this Paris
Oh,
Agreement is essential for present and future generations to attain a more secure and stable environment. Okay.
okay. Yes.
So yes, it is given in 2015. So in essence, this Paris Agreement has been about safeguarding people from such an uncertain and progressively dangerous environment and ensuring everyone can have the right to live in a healthy, pollutant-free environment without the negative impacts of climate change. So we all know why climate change is going to occur because of the use of fossil fuels for power generation methods. Okay.
Yes.
So from there, this renewable energy research has been started in many countries. So that is
Correct.
about Paris Agreement. We also have Sustainable Development Goals. That is also given by the United Nations in 2015 and recognize them as international legislation which demands a global effort to end poverty, safeguard the environment, and guarantee that by 2030. So the goals are given
Mm.
to be reached by the year of 2030. Fine,
Yes.
and consequently, progress needs to be balanced among economical. That is fine. Okay. So that is about two important protocols or agreements they were given.
Yeah.
Okay. And if you see
Yes.
the installed capacity of solar energy worldwide has been rapidly increased to meet energy demands. So this solar energy can be used for electricity generation as well as there are different applications which are known as concentrated solar power, that is CSP. Okay, one side we have
Yes.
concentrated solar power, another side we have solar installations which will be used for electricity generation. So if you see the variation of that, the installed capacity of PV technology, here PV technology means which are going to be used for electricity. Okay.
Okay.
So
Yes.
from 2010 to 2020, that PV technology has been increased from 40,334 to 7 lakh 9,674 megawatts. It is a huge rise there. And whereas the
Correct.
installed capacity of concentrated solar power applications are from 1266 megawatt in 2010 to 6,479 megawatt only. That means the rise is more in the PV technology rather than in concentrated solar power applications. Okay. So that is only said here. The standalone solar PV and large scale grid connected PV plants are widely used worldwide and used in space applications as well. Fine.
Yes,
And
correct.
we got several applications of this solar technologies, and they are given here applications of solar technologies. And we can use solar PV for reducing the salt content in the sea. So that is known as desalination technology. Fine. And we have PV arrays which are having 30-year lifetime, and they can come in various shades based on the type of material utilized. So we have different materials, right? Like silicon
Yes.
or whatever it is. So based on them, several shades are there. And we have PV thermal technology. So this PV thermal technology comprises conventional solar PV modules, which are coupled with a thermal collector mounted on the rear side of the PV module. And it is used for preheating domestic hot water. Okay. And this is
Yes.
one application. We can have a solar PV water pumping system. Okay, we can use the solar PV for pumping water to the tanks and all through motor,
Yeah.
motor. And we can also have solar cooling. What is this solar cooling? What can you get from solar cooling?
We can. Do we get the thermal energy from water? Or no,
So it
I'm not
is solar
aware.
cooling indicates like it is used for the application of cooling, like room cooling. It can be air conditioning. You can say coolers are there. That means solar can be used for supplying input power to those devices which are used
Okay.
for cooling purposes. Okay.
Yes.
And we can also have some PV powered cathodic protection system, which will be used to control the corrosion of a metal surface. So that
Okay.
also
Yes.
can be used with the PV technology. So here in this figure, if you see, there is huge rise in the uh, installed capacity of solar photovoltaic. If you see this very thick orange
Yeah.
color is indicating solar thermal, which is very less when you compare with solar photovoltaic. Okay.
Yes.
Yes, the solar photovoltaic means which is used for electricity generation. Solar thermal means which is used in thermal applications. Okay.
Yes.
And here,
Good.
as I said, there are various applications. Mainly, they are categorized into two types. One is sort of solar photovoltaics. One is CSP, that is concentrated solar power. And this CSP, there are different types like parabolic trough, power tower, dish engine. And in photovoltaics, we have PV electrification, PV water pumping, PV cathode protection, PV desalinations. And
What
yes,
what's the difference? Like, what is the photo? No, not the on the left.
parabolic trough.
Could you explain it more? Yeah.
Yes, yes, it is there
Like
here. I will tell
like
you.
category. Okay.
Yes. So
Sure.
here parabolic trough means that is an application of concentrated solar power, right?
Yes.
So the concentrated PV technology uses either the refractive or the reflective concentrators to increase the sunlight to PV cells. Means that sunlight is very much concentrated in that. And high
Yeah.
efficiency solar cells are usually used for that, consisting of many layers of semiconductor materials that stack up on top of each other. Okay, and this particular technology has an efficiency of 47%. So in case of solar PV technology, 47 itself is more. He's saying that
Yes.
we cannot get like transformers 95, 95, 99 percentage. Okay, right.
Yes.
And if you see for
Yeah.
solar for concentrated solar power PV systems, the solar rays are concentrated using mirrors in this application, and these rays will heat a fluid resulting in steam used to power a turbine and generate electricity. Fine. So these CSP systems can also be indirectly will be used for generating electricity only.
Okay.
So through boilers and
Okay.
all.
Yes.
Okay.
Yeah.
And you are asking about parabolic trough, right? Let us see where it is.
No, I was asking about the CSP.
Oh,
What
you are
does it
asking
mean?
about CSP only.
Yeah, yeah, yeah. CSP only.
Yes, yes, that means that is CSP. So in CSP, mainly the light will be concentrated and many layers of solar cells will be kept so that that the heat effect will be more, and that heat will be used to power the turbines and all.
Yes, clear.
See, like steam turbine is there, we can use for water heating and generate the steam so that it will drive the turbine and generate the electricity.
Correct. Clear. Yes.
Yeah, so similarly, we have some applications of CSP like parabolic trough technique and desalination also employs CSP technology that utilizes hybrid integration and thermal storage, which allows continuous operation and is a cost effective solution. So, solar thermal can be used for domestic purposes such as dryer, and in some countries or societies, the so called food dehydration is traditionally used to preserve some food materials such as meats, fruits, and vegetables. Yes, we will see in shopping malls, right?
Yes.
So, where for cooling purpose, the solar technique can be used. So, now
Correct.
what is the role of solar energy in sustainable development? So, what is sustainable development? First of all, sustainable energy development is defined as the development of the energy sector in terms of energy generating, distributing, and utilizing that are based on sustainability rules. So, this renewable energy sources comes into this because they are sustainable. They comes without any negative impacts, right?
Yes.
So we can say them as sustainable, and this sustainable development includes utilizing renewable energy applications, smart grid technologies, energy security, and energy pricing, and having a sound energy policy. Because we cannot directly install, everyone may not be preferred to install renewable energy sources because there will be certain installment cost, investment cost will
Correct.
be there. So there should be certain energy policies which encourages these installments, so which can be given by the
Correct.
government only. So initially if they give that policies, then accordingly people can prefer to install them. So all these
Correct.
energy security, energy pricing, all these are interrelated so that that sustainability can be achieved. Now,
Okay.
now the perspective of solar energy is there. So here the distribution of solar radiation and its intensity are two important factors which influence the efficiency of solar PV technology. So he's saying the distribution of solar radiation as well as its intensity. So that we will see, and these two parameters vary among different countries based on the availability of sunlight in that particular country, and that depends on various factors. There are various angles. Suppose if your country is close to the equator, you might be getting more sunlight, yes or no?
Yes. Correct.
Yeah, something like that. It will be varying in different countries. So therefore it is essentially to realize that some solar energy is wasted since it is not utilized. On the other hand, solar radiation is abundant in several countries, like which are close to equator, let us say, and especially in developing ones, which makes it invaluable. Okay, fine, that is general. So this is the framework of solar energy applications in energy sustainability. So the solar energy applications helps environment, which will be leading to the sustainable development, and it will also improve economics, financial development due to the
Correct.
presence of various jobs. We will see how various technologies have influenced the number of jobs over the in the world. So if you see through these all these new generation technologies, we could get some 12,000, 18,000 jobs. So this number of jobs is in thousand. Okay.
Oh,
Yeah.
yes.
So and solar photovoltaic is having much contribution in creating jobs rather than other technologies. Then we got biofuels, hydropower is there next, Hydro means water generation, water electrical generation. And we have wind, and we also have solar heating, cooling that is given separately. So we have
Yeah.
geothermal and some other CSP. CSP is there with
Mm.
31.9 thousand, and tide, wave, and
Yes.
ocean energy could generate 1.3 thousand. Okay. So with
Yes.
this, you can understand how much impact they created for financial development of the countries. So this is also country-wise given here. So here we have seen the variation with respect to the technology. Here this table is with respect to the countries. So in the continent wise, it is given for various countries. So you can see for
Yeah.
China, so many jobs were created in China, and Japan, US, India is also there in the top four, and we have Bangladesh, and going on like that. Okay.
Yes.
Yes. Now, if you
But
see here, some numbers are there here. The CSP stations have been in use since the early 1980s. Okay. The CSP power
yeah.
stations in the USA currently produce greater than 800 megawatt of electricity yearly, which is sufficient to power 5, 5 lakh houses. So new CSP heat
Okay.
transfer fluids being developed can function at this much temperature, which is greater than existing fluids, okay, to improve the efficiency of CSP systems. Okay, and here if you see, there was some desert tech project which has drawn out the possibility of CSP in the Sahara desert regions. Okay, if you want to specify some real time examples or real world examples, these things you can mention in your introduction presentation. Okay.
Okay. Yes.
Yes, so when completed, this investment project will have the world's biggest energy generation capacity through the CSP plant. So it is specifically focused with CSP plant, this Desert Tech project. So you can see when it can be completed or when it is started. In these references, it is available. Okay.
Yes.
42, 43. Okay, this is the thing given here, average annual ground solar energy, clear sky insolation incident, horizontal surface, kilowatt hour per meter square per day. I will tell you all these parameters. Okay, what is insolation, what
Yes.
is meant by clear, we will see.
Okay.
Okay, so this is
Yeah.
about the literature work here. So here it is saying the technology that converts solar radiation into electricity is well known and utilizes PV cells, which are already in use worldwide. In addition, various solar PV technologies are available today, including hybrid solar cells, inorganic solar cells, and on. Okay, but here it is saying so far solar PV devices made from silicon have led the solar market. Okay. However, these
Yes.
PVs have certain drawbacks. That means which are made from the silicon having certain drawbacks. He's saying they are
Yes.
like expenditure of material, time consuming production, etc. So it is
Yeah.
important
Yeah.
to mention here the operational challenges of solar energy in that it does not work at night. So okay, that is with respect to material, those are the challenges. But with respect to operational, what are the challenges? We cannot get solar energy power available during night. So that is one operational challenge, and has
Yes.
less output in cloudy weather. That is also one constraint, because
Disadvantage.
even in the noon, if it is cloudy, we cannot get power and does not work in storm conditions. So PV
Okay.
battery storage is widely used to reduce the challenges to gain high reliability. So this I already told in the first class itself. So in order to
Yes.
compensate these challenges, we need to use some other sources or options.
Correct.
So one better option is solar battery storage. Okay.
Yes.
So attempts have been made to find alternative materials to address these constraints, like alternative to the silicon. And currently, this domination is challenged by the evolution of emerging generation of solar PV devices based on some organic and organic inorganic. So some other materials are being studied. Okay,
Yeah.
so
Yes.
like organic, inorganic, hybrid materials, they are saying. So this is about this particular work. So we have discussed about Paris Agreement and we have discussed sustainable energy development goals and the various applications of solar energy, like maybe
correct.
photovoltaic is there, and we have CSP, concentrated for solar photovoltaic, and then we have seen how it is affected for sustainable development goals and for sustainable development mainly. So like how it is helping environment, how it is creating financial and economical development and all. So we have seen some real world projects like desert tech is there, and also a few numbers we have seen, and some
Yes,
challenges I have discussed, like based on materials we have challenge, and based on
yes,
operational challenges, like it is not available throughout the day, so we need to check
yes,
for other possibilities which can be operated along with the PV for reliability increase. Okay.
yes,
Okay, this is all about this particular work so that you can get some literature works and present in front of your committee. Now, now I will just tell you the importance of the solar parameters. So in this thesis work, future of renewable energy penetration in Kuwait as oil producer country. Fine. So
yes,
this has been done as a part of MSc thesis. So we will see what are all the things presented here and why we need to know solar parameters in order to understand this thesis. Okay.
yes.
Okay. So there are so many contents here. So I just checked some contents and highlighted some points. Let us see. Okay, see, the energy sector in Kuwait is witnessing far reaching and rapid changes. Reduction in costs, policy, and innovation frameworks are fueling unprecedented growth of renewable energy across Kuwait. The urge to address climate change and advance sustainability in Kuwait are also strengthening the energy transition momentum. Okay. In
Yes.
Kuwait, only the solar energy will add 10.3 gigawatt. Photovoltaic panels portion will be 45%, and concentrated solar power is the remaining 55%. So now if you read this, you can understand what is meant by concentrated solar power. Okay. That's why we discussed before this, and is the
Yes.
remaining 55% of the total renewable contribution. Fine. So locally in 2017, Kuwait announced its new Kuwait vision. So this is also very important for you to present in front of your committee. You need to mention this. There is a vision considered which as new Kuwait vision. Okay. So what it
Yes.
is, you need to know about it. So it included
Okay.
multiple pillar of diversification of the economy and creating more sustainable life. So that included investing in sustainable technologies and higher implementation of renewables. The total renewable energy contribution on 2017 was less than 1% of the electric grid. By 2020, Kuwait's share of renewable should have increased to be 5% of its electricity supply. Okay. Since
Mm.
2016, different institutions like Kuwait Institute of Scientific Research and Kuwait Oil Company from different sectors have been investing in solar energy and less in wind energy in their projects. So that means in Kuwait also mainly people are investing in solar energy only and less in
Correct.
wind energy. Okay.
Yes.
However, the last decade witnessed over 70% drop in crude oil prices in Kuwait in comparison to its highest average. That means he is saying there is huge drop in the oil prices as well. According to
Okay.
the information presented by Kuwait Institute of Banking Studies, during the most recent drop in oil prices, which occurred in April 2020, Kuwait lost at least $20 billion of its income from oil because of the price reduction. Because people are not
Okay.
preferring it, right? Everyone is going for
Correct.
renewable sources.
Yes.
So, yeah,
Correct.
that's why demand is less. So, they should reduce the price. So they lost a lot
Mm-hmm.
of income. Okay, high government deficits and the raw experience in renewable technology raised technical challenges about the possibility to achieve 15% renewable energy contribution by 2035 as a new Kuwait vision target for sustainability. So, are you getting what is the target of new Kuwait vision?
Yes.
It
Yes.
is to achieve 15% renewable energy contribution by the year 2035. Okay,
Yes.
so this work or thesis has looked upon the possible scenarios where this could be achieved from an engineering perspective. Okay,
Yes.
and brief profile of the Kuwait has been given here, and you can check this.
Yeah, I will check this. Yes.
Yes, and aims and objectives are there. So to find the best arrangement of renewables like solar PV and wind turbine for Kuwait with highest potential for reducing the load on grid. So whatever we do, it is for reducing the load demand on the grid, right?
Yes, correct.
And to find possible penetration percentage of renewable energy in year 2030. That means how much percentage of renewables can be penetrated into the grid with the
Okay.
assumption that electricity demand in Kuwait grow at the same rate annually and economy in Kuwait grow at the same rate. Because these assumptions are required because we are going to check for the future. Okay. Yes or no?
Yes, correct. Yes.
Yes, yeah. So there should be some assumptions and overview of the methodology is given. So based on the literature, we need to know the location and size and its population first and its financial state, then environment and climate, CO2 emissions, and create an electricity demand profile for Kuwait. We need to know that and energy portfolio
Yes.
map of the current grid mix. That means which kind of technologies are being used currently for supplying power to the load and forecasting of the demand average type of household selected ongoing projects we need to know. Okay, then resource potential resources means wind energy and solar energy and we need to assess the
Yes.
suitability for solar energy, the amount of irradiance and prove it's enough for solar applications and assess the suitability of wind energy. We need to know the locations should be used, sizes, wind speed in Kuwait at different locations, and we need to then choose software which software can be used for knowing the impact of all these possible resources. So based on the
Yes.
objectives of the project, multiple software might be used which will help in assessing renewable energy system in detail. So then the location for the analysis will be selected, details of the location will be provided, meteorological data is added, okay. Input details and prices of system components and grid are determined, they will be used in Homer. Two main scenarios will be considered financially and technically. One to determine the feasibility of 15%. Okay, that should be the target. We need to determine whether it will be possible or not based on modeling of ongoing projects in Kuwait, and other to aims to maintain for year 2030. First, they check for the target of 2020, then they checked for 2030. So maybe
Okay.
if
Yes.
you go through the complete thesis, we can understand. Assess the energy price after introducing renewables. So how the energy price is going to be changed after the introduction of these renewable energy sources. That should also be known.
Sure.
Okay,
Yes.
then you just okay. Now, in order to know all these things, the location aspects and solar parameters, in order to know their impact, we need to know like various parameters of the solar. So we will discuss all those things now. Okay.
Yes.
So if you see here, solar potential is given. So here they are giving many technical parameters related to the solar. So if you see here, the global horizontal insolation is one parameter, which is proportional to clearance index. So we need to know what is clearance index, and we also need to know
Sure.
average extraterrestrial solar insolation. So all these things are important. Let us see all those things now.
Okay.
Okay. So for that, I created one document for you. So this is the
Yes.
document which gives you many parameters of the solar technology. Is it visible?
Thank you. Yes, it's visible.
Yes, yes. Okay. So now you see, so there are several parameters. So the solar photovoltaic
Yes.
technology is a renewable energy source that converts sunlight into electricity. Several parameters and factors influence the performance and efficiency of solar PV systems. So here are the key parameters and concepts associated with them. So first one is solar insolation. So you might have seen or read this word solar insolation. What it is? So it is actually short form for the incident solar radiation. Okay.
Okay.
So insolation is abbreviated from this incident solar radiation. In solar rad. Okay. Radiation. So it is the amount of
Okay.
solar energy received per unit area over a given time. So this is important that it is the solar energy received per unit area. What are the units of area? It is meter square. So it is measured
Correct.
in watts per square meter. Okay. So the
Yes.
units are also very important. Different parameters will have different units. So then we have extraterrestrial insolation. So what is this extraterrestrial insolation? So this parameter represents the solar radiation that is received at the top of the Earth's atmosphere. So that means that in atmosphere also there are various parts, like we have
Yes.
some monosphere, something like that.
Yes.
Some three,
Yes.
four parts are there. So this is at the top of the Earth's atmosphere. So whatever is the radiation received at the top of the Earth's atmosphere is nothing but extraterrestrial insolation. Okay. And it is the maximum solar radiation available under ideal conditions. So if there are no other losses in between, that complete radiation will be reaching the Earth's surface. That is the ideal condition, right?
Yes.
And it will be affected by the Earth Sun distance, which is given in terms of solar constant, and it varies throughout the year due to the Earth's elliptical orbit. Yes or no?
Yes.
Because the Earth will be continuously rotating around the Sun, so that will be there.
Correct.
So due to that, the distance will be varying, so the radiation will also be varying.
Yes.
Now
Correct.
we have another parameter, global horizontal insolation. So here this global horizontal insolation is the total solar radiation received on the horizontal surface at a specific location. So this is specific to a location. Fine.
Yes.
So it includes both direct sunlight and also diffuse radiation, which is like scattered sunlight. So whatever is
Okay.
the
Yes.
sunlight that can directly come, and it can also come in a scattering manner. So that means from other materials it can come.
Correct.
So which is indirect. So that depends on the sky's condition. So direct is the beam radiation, indirect is the one scattered one. So it is measured in kilowatt hour per meter square per day. That means it is measured like energy, not power. So here this insolation, solar insolation is measured in watt per meter square. But here this is
Yes.
kilowatt hour per meter square. That is the difference.
Yes.
So because it
This is
is per
important.
day. Okay, now
This
we
is
have another parameter that is direct normal insolation. So it is saying that DNI, it is abbreviated as DNI, it represents the solar radiation received directly from the sun on a surface that is perpendicular to the sun rays. So the surface
okay.
can be orientated in many direction. So, but here, in order to know this normal insolation, we will consider only the surface which is perpendicular to the sun rays.
Okay.
And it is not affected by diffuse radiation, right? So, diffuse radiation is the one which is not direct, so it is indirect. So, but this normal insolation is saying it should be perpendicular. Perpendicular means it is
Correct.
direct.
Yes.
So that's why it is not affected by diffuse radiation, and it is also measured in watt meter square or kilowatt hour meter square. It can have any unit.
Okay.
So what do you
Very
think
good. Okay.
this DNA is important for photovoltaic or CSP?
I think it's a CRC.
CSP, yes, because it is based on concentrated, right?
Yes.
So that is only given here. DNA is particularly important for CSP and also solar trackers. Okay, fine.
Yes.
Now, coming to the location, we need to know the latitude and longitude, right? Do you know what is
Longitude.
latitude?
Yes. No.
Yes.
No.
So the latitude is given for any location in this world. So each location will have some latitude and longitude. We will see what it is. So this latitude
Okay.
is a geographic coordinate that specifies a location's north-south position on the Earth's surface in relation to the equator.
Okay.
Okay, you know there is an equator in at center of the poles.
Yes.
So with
Correct.
respect
Yeah.
to
Yeah.
that equator, how our position of the our location is located at which coordinate. So you might have
Yes.
seen coordinates on xy plane. We generally have 1 comma 1 2 comma 0, something like that. Like
Yes.
that, the earth plane will have some coordinates which are given with respect to latitude and longitude, and this latitude specifically gives the location with respect to north south position, whereas longitude gives the position with respect to east west. That's it, that is the only difference.
Okay. Okay.
Now
Yes.
I
Okay.
will tell with an example. So latitude is measured in degrees because it is an angle with values ranging
Yes.
from 0 degrees at equator to 90 degrees north at the north pole. So we have
Yes.
90 degrees difference with respect to north. We have 90 degrees difference with respect to south, right? Yes or no?
Yes.
From the equator.
Correct.
Yes.
Yes.
So it can be given like 90 degrees north. North means it is towards the north. South means it is toward the south from equator. And if it is exactly,
Correct.
if some country or location is exactly in line with the equator, then we can coordinate it with 0 degrees.
Correct.
Okay, the
Cl-
equator located at 0 degrees latitude is an imaginary circle that circles the Earth's circumference and divides the planet into the northern hemisphere and the southern hemisphere. Latitudes are also used to define how far north or south a specific point is from the equator, right? Okay.
Yes.
Now, for example, locations near the equator have low latitudes, yes or no? Like
Yeah.
Ecuador is there,
Yes.
Quito is there,
Yes.
and
Zero
locations.
one.
Yes,
Yes. Correct.
yes. Now locations in northern hemisphere have positive latitudes, and like New York City, USA, at approximately 40 degrees latitude north, and we have in southern hemisphere have negative latitudes. So that means from the equator, the anti-clockwise will be north. Yes or no?
Yes.
From equator, anti-clockwise is north and clockwise is south, right?
Yes.
So he is saying northern will be having positive latitudes. That means anti-clockwise is considered as positive angle, and clockwise
Yes.
angle is considered as negative. Like
Okay. Okay. Yes.
Sydney, Australia at approximately 34-degree latitude south.
Okay. Clear. Yes.
Means it is negative angle. So similarly, the North Pole is at 90 degrees north, South Pole is it at 90 degrees south. This is all about latitude. Okay. But why it is
Yes.
important? So this latitude plays a crucial role in various applications, maybe for including navigation, climate and weather patterns, and the positioning and orientation of solar panels for solar energy systems. So based on the latitudes, we can decide how to orient the solar panels. Okay. So
Okay,
it is a
yes, yes.
fundamental concept in geography and cartography for defining points global position. That's fine. Okay, now what is longitude? That is all about latitude. And similarly, we can have longitude, which specifies the east-west position of a location and affects the local time, which in turn influences the solar angle and the timing of peak solar insolation. Fine.
Yes, fine.
The only difference is east-west, whereas latitude is north and south. That's it.
Correct.
Now
Yes.
coming to the hover angle, there is one important angle which is hover angle. So this hover angle is a measure of the time since solar noon at a particular location and is expressed in degrees, and it helps in determining the position of the sun in the sky and is useful for calculating the solar zenith angle. We will see what is this zenith angle and all. So first of all, this
Okay.
hour angle is the measure of the time since
Yes.
solar noon. This is very important. At what time is considered as noon?
12.
12, right?
12.
Yes. So that's why in order to calculate hour
Yes.
angle we use 12 in the formula. I will tell you how it is. So we will
Okay,
discuss
yes.
about this hour angle afterwards again in detail. But then we will see what
Yes.
is solar zenith angle. So this solar zenith angle is the angle between the sun and the vertical line pointing to the observer's location. So are you getting this point? Suppose you are the observer and you are at some location, right?
Yes.
So we can draw a vertical line pointing to the observer from the sun. No,
Okay,
there
yes.
will be a vertical line above your head.
Okay.
So that line and the sun, there will be one angle difference. Sun's position
Yes.
and this vertical line will have some difference in angle because sun
Yes.
will not always stay above our head, right?
Correct. Yes.
So this angle is considered as zenith angle and it helps determining the height of the sun in the sky. I will tell you how this
Okay.
height will be determined and is essential for calculating the solar irradiance, right?
Yes.
So there is one term solar irradiance and we have studied solar insolation. They are mostly same, but there is small difference. This irradiance is given at a particular instant, whereas solar insolation is a measure of the total solar energy received over a specified period. Okay, like daily,
Yes.
monthly, or yearly. Generally, they can be used interchangeably. It is fine. So in research works and all, you will see they are used interchangeably. Okay.
Yes.
Okay, now this solar irradiance is a measure of the instantaneous solar energy power received at a specific point in time, offering a snapshot of the current sunlight intensity. Just now I told, right?
Yes.
Whereas this solar insolation is with respect to some period. Okay, so that is one angle, zenith angle. We also have one azimuthal angle, right?
Yes.
So this azimuthal angle is the compass direction. What is meant by compass direction?
The come
Yes, the four
north.
directions that we have.
The north. Yeah.
So like north, south, east, and west. Okay.
Correct. Correct.
So azimuthal angle is the compass direction in which a solar panel or collector is facing relative to the geographical north. So this angle is given with respect to the north. Okay.
Okay.
How the solar
Yes.
panel or collector is facing with respect to the north. That means if it is at the south, what will be this angle? 180 degrees. Okay.
Yes.
If it is at east, if the solar panel is facing east, what will be the azimuthal angle? It will be
90.
90
90.
degrees, but in clockwise
Mm.
direction. Okay.
Yes.
And if it is west, it will be anti-clockwise 90 degrees. So like that, it can have angle from 0 degrees to 360 degrees.
360.
Okay.
Yes.
So that is only given here. In case of north, it is 0 degrees or 360 degrees. And in case of east, it is 90 degrees. In case of south, it is 180 degrees. In case of west, it is anti-clockwise 290 or overall 270. Fine.
Yes.
We can also have northeast, we can also have southeast, we can have northwest and southwest. Okay.
Yes.
So all these possibilities are there for solar panels to face. So accordingly, this azimuthal angle will change.
Okay.
So that means
Clear.
azimuthal can angle can vary from 0 to 360 degrees.
Correct.
So the choice of azimuthal angle depends on the specific location and the desired solar exposure to optimize energy capture. Fine.
Yes.
Now we will see what is this clearance index. So we have seen the term in that thesis, right? So we will see what
Yes, we
is
saw.
this. So the clearance index is a measure of the shading and obstruction in the vicinity of the solar PV system. That's it. It is very clear. So it accounts for nearby objects like buildings, trees, and other obstacles that may cast shadows on the solar panels. Fine.
Yes.
So this is very clear, right?
Yes,
So the
that's clear.
clearance, yes, a higher clearance index means fewer obstructions and better system performance. That's it.
Correct. Yes.
Yes, if the index is more, that means it is very clear. So no obstructions.
Yes.
Now, in order to optimize the orientation and tilt angle of solar panels, do you know what is tilt angle?
No.
That means solar panels are not kept always horizontally, right? We need to tilt it
Yes.
with respect to the sun's position
Correct.
for maximum efficiency. So, how to decide that? How to optimize it? So, that depends on these parameters. Okay.
Okay.
This
Yes.
involves considering the latitude, azimuthal angle, and the movement of the sun throughout the day.
Okay. Yeah.
Proper site
Correct.
analysis and system design are essential for achieving the best solar PV system performance. Okay,
Yes.
right. Now, optimizing the orientation and tilt angle of solar panels based on these parameters is crucial. But how it is done, right?
Yes.
Yes. So first we need to determine the location, right? So you need to identify the exact location of your solar PV installation, including its
Yes.
latitude and longitude coordinates. And this information is critical for calculating the sun's position throughout the year. Okay. Then you need to calculate the solar zenith angle, and you also need to determine the azimuth angle, and then you need to calculate the tilt angle for maximum
Yes.
efficiency. So, but what is this tilt angle? Now we will see. So, the tilt
Okay.
angle, which is also called the tilt or elevation angle, is the angle at
Yes.
which your solar panels are tilted relative to the horizontal surface. So, this is very important. So
Yes.
this is relative to the horizontal surface. So the optimal tilt angle depends on several factors, including the system's purpose, whether it is grid tied, off grid, or seasonal, comma, the latitude and
Okay.
the local climate. So to maximize the annual energy production, it is often set close to the latitude of your location. So this is very important point. Are you getting? In
Yes.
order to maximize, it is kept close to the latitude of your location. That's why latitude is important to be knowing.
Okay. Yes.
Okay, the tilt angle is close to that. It may not be always, this is the only solution, but on an average, this can give you the good performance.
Okay. Clear.
But you need to consider the seasonal adjustments. So, based on the season, your tilt angle can be changed. So, because in some cases it might be beneficial to adjust the tilt angle seasonally. For instance, you can set a higher tilt angle in winter to capture more sunlight. Yes or no?
Yes.
when the sun is lower in the sky, and at lower tilt angle in the summer to capture more sunlight when the sun is higher in the sky. Okay,
Yes.
that means tilt angle can be varied with respect to the season.
Okay.
So
Clear.
once you
Yes.
know all these parameters, you need to decide the software tools. So various online tools and software applications are available that can help you calculate the optimal orientation and tilt angle for your solar panels. So I think I have seen some link you have sent me,
Yes.
and there also different parameters if you give input. So they might be giving you the tilt angle and the power available with the desired installed capacity of solar PV. Okay.
Okay.
So I will see that once. You can also check. If I'm able to understand, I will tell you all those things.
Sure.
So these tools take into account your location, the tilt angle, azimuth angle, and other parameters to provide precise recommendations. Fine.
Yes. Just to make sure, uh, I wrote my aims and objectives.
Okay. Hmm.
Do you want me to send it to you to see uh
Yes,
to
if
your
you can share, you
email?
can share in the class only so that we can discuss.
Sure.
Maybe if
Okay,
you want to
then
share now, you can share.
I will see. Yeah, yeah. Okay,
Okay,
I will
if you
try to.
finalize and send otherwise.
Yeah, it's small. It's small, not too many
Yes,
data.
okay. Do you want to show it to me now?
Yes, it's possible with you.
Yes, yes. We have 5 more minutes. You can just show me.
Sure, I will.
Yes, share.
Make this, I will send it now. Just a minute.
Yes.
I'm not sure why it doesn't shows me.
So you are unable to share or what?
Yes, I can share, but I'm not sure where's the file. I can't
Oh,
detect it.
okay. Then you send me. I will see. We can discuss in the next class.
Sure.
Okay, then we will finish it here now. So in the next class, we can continue with details of the parameters. Then maybe based on the objectives, we can proceed further.
Okay. Thank you so much.
Fine?
Thank you.
Okay then.
Yes.
Yeah.
Thank
Bye.
you. Have a good day. Bye.